Hello everyone. In this video we are going to discuss what is indices, right? So it's the plural of the term called index, right? If we see, let's for example 2 to the power 3, this we know can be written as 2 times 2 times 2, right? Now the product is equal to 8, right? So we say the shorthand notation for writing 2 times 2 times 2 is equal to 2 to the power 3, right? So here 2 is known as the base, right? And 3 over here is called as power or index, or also known as exponent, right? So in order to solve for say 2 raised to the power 3 times 2 raised to the power 5, right? So you can say 2 raised to the power 3 can be written as 2 times 2 times 2, and 2 raised to the power 5 can be written as 2 times 2 times 2 times 2, that is 5 times. So these 5 are for 2 raised to the power 5, and the first 3 are for 2 raised to the power 3, right? So I can write the reverse of 2 times 2 times 2 as 2 to the power 3. Similarly, over here you have 8 times 2 is multiplied, so that is equal to 2 raised to the power 8. So we say 2 raised to the power 3 times 2 raised to the power 5 equals 2 raised to the power 8, right? So there is a relation between 2 raised to the power 3 times 2 raised to the power 5 that gives you 2 raised to the power 8, right? So we have certain laws in indices which we use to solve them quickly, right? So let's go through those laws now. So the laws are true in certain constraints, like let's define first. So similarly, if I give you in general, let's say we have a raised to the power m, you will call a over here is your base and m is your, let's say we will use index, it is also known as power or exponent, right? So we will now define, given a, b, m and n are real numbers, okay? So I am stating down the rules. If I say a raised to the power m times a raised to the power n, so it's multiplication of two terms that are in index form, right? Some number raised to the power. So this results in a raised to the power m plus n, right? Similarly, if we look at the second thing, the second law states a raised to the power m divided by a raised to the power n. This will be equal to a raised to the power m minus n, right? Similarly, third law, a raised to the power m raised to the power n, this will be equal to a raised to the power m times n. So it's multiplication, we use a dot symbol here, right? So these three laws, we will look at some of the examples after I state all the laws. So we are done with three laws. Let's write down the fourth law. It states, if I say a raised to the power m times b raised to the power m. In the previous laws, you will say the base was same. Over here, the base is different, but the index is same. So we can write this as ab raised to the power m, right? Similarly, a raised to the power m divided by b raised to the power m, we can write it as a divided by b raised to the power m, which can be also written as a by b raised to the power n, right? Let's move to the next law. So we will call 5 and 6 as laws with same index, right? Now the sixth one, I will say a to the power 0 is equal to 1. Given condition, a should not be equal to 0. So for all the laws I have written, it should be a real number. But for sixth law, you will say if a is not equal to 0, then this thing is true, right? Let's look at the next law. If I say a raised to the power minus n, this will be equal to 1 by a raised to the power n. Here also a should not be equal to 0, right? Let's look at the next law. So there are two more laws. I will say if I have a raised to the power 1 by n, this can be written as nth root of a, right? Here the condition is a should not be negative. So let's write it down, a should not be negative. Okay, let's move on to the last law. So it states, if I have something of this kind, a raised to the power m divided by n, this can be either written as a raised to the power m raised to the power 1 by n, right? That will, you can now write this using the 8th law as nth root of a to the power m, right? Or you can write this as a raised to the power 1 by n whole raised to the power m. So this will be equal to nth root of a whole raised to the power m. So any one you can choose, right? So the condition over here, you can say a should not be negative, right? So in the 8th and the 9th one, a should not be equal to negative, right? So usually some of the common mistakes made, I'll just list down. What students do is 2x raised to the power 3, they write it as 2 raised to the power x cube, but this is not true. This means you are going reverse with the 4th law. You can say this will be equal to 2 raised to the power 3 times x raised to the power 3. So the output that you get, 2 raised to the power 3 is 8. It will be 8 times x cube, and you know that 8 times x cube is not equal to 2x cube, right? Similarly, if I take one more example, like 2 raised to the power 3x, what students usually do, they write it as 2 raised to the power 3 times 2 raised to the power x, but this is not true, right? Rather, what you can write this as 2 raised to the power 3 whole raised to the power x. That gives you 8 raised to the power x, whereas this will give you 8 times 2 to the power x. So this is true, right? So these mistakes are to be checked on. Okay, in the next video I will be solving some questions using these laws.